What I'm going to do now is show you how to design your own customized targeting cone using Solidworks. The first step will be to open a targeting cone design template file, which you can download from the OpenEFIS website. Here I'm going to use the rostral template file because I'm planning to insert probes anterior to bregma. The version of Solidworks that I'm using here is the 2014 Student Edition, which we use for teaching here at UCLA. If you are using a different version of Solidworks, then some of the commands that I describe here might differ slightly in your version of Solidworks. When the file finishes loading, you may, depending on your version of Solidworks, get a build error like this. In all likelihood, that's not too serious, so you can just hit close and ignore that. Now you can see a three-dimensional rendering of the targeting cone here in this view window. And for those of you who might not be familiar with SolidWorks, now I'm going to explore some basic techniques for manipulating the view of a three-dimensional object in SolidWorks. So I'm using a mouse that has a rotary wheel on it, and I strongly advise using a mouse with a rotary wheel when you use SolidWorks, because one of the useful things you can do with that is if I left-click anywhere here in this window, I now acquire the ability to use the rotary wheel to zoom in and out from any point that I select by pointing at it with my mouse cursor. So anywhere I point with the mouse cursor, I can zoom in and out on that point by rotating the rotary wheel. I can also press down and hold the rotary wheel as a button, and then if I move the mouse, I can turn the object and view it from just about any angle. Another very useful tool for manipulating your view of the object is to come up here and click on this View Orientation button at the top of the screen. That places the object into a standardized orientation and displays these planes that you can use to select different views of the object. So if I click here on the front plane, I see a front view of the object. Now I'll click on the View Orientation button again, and this time I'll choose a bottom view of the object. Click on View Orientation again. This time I'll choose a side view of the object. And these views are simply starting points. From any starting point I can then zoom and rotate as before using the rotary wheel. So let me click on View Orientation once more, and starting from this standardized view, let's explore some of the features of the targeting cone. So let's start from the top left corner here and look down on the targeting cone from above. You can see this funnel-shaped opening at the top, and this is where the drive core will mate with the targeting cone to form the finished drive later on. If we go back to the standard view and look from the bottom, this is the bottom surface of the targeting cone, and this gray area here is the pedestal that will actually make contact with the rat's skull during surgery. So if we zoom in on this, you can see some of the details. This hole here is going to be at bregma, and this hole in the back is going to be at lambda. This rostral version of the targeting cone template is for doing surgeries where you implant anterior to bregma or in between bregma and lambda. If you want to implant posterior to lambda, then you should use the caudal targeting cone template. Notice that the bottom of the pedestal is laid out in a grid that's 1 millimeter by 1 millimeter square. So it's very easy to see where positions that reside 1 millimeter anterior, 2 millimeters anterior to bregma, for example, or 1 millimeter, 2 millimeters lateral, 1 millimeter, 2 millimeters posterior to bregma, and so on, are located. And if we rotate this view a little bit, you can also see that the bottom surface of the pedestal is actually contoured to fit the surface of the rat's skull. So when this is placed on the rat's skull, it will fit snugly onto the surface of the skull, and that will form a very tight fit for a secure, stable, and long-lasting surgical implant. A couple of other features to point out are these holes here, through which bolts will be fitted to mate the targeting cone to the drive core when we finish the drive, and then also these holes here, through which some feet that are attached to the bottom of the drive core will be slid so that when we mate these two things together and do the surgical implant, the acrylic that we use to fasten this to the skull will be able to bind not only the targeting cone but also the drive core itself to make sure that this is a stable and long-lasting implant. So let me go back to the standard view now. Before we conclude this introductory video, let me point out a few other useful things that will be helpful for you to know as you watch the next series of videos. One thing is that you can see over here on the left this list of components for this targeting cone template file. The other is that you have various tool buttons and commands across the top here, which we'll be using as we design our own targeting cone in the next videos. And it's important to recognize that there are these tabs here. The assembly tab is the one that's selected now, and these commands that you see here are specific to the assembly tab, but the sketch tab is another one that we'll use, and there's a completely different set of tool buttons on the sketch tab. So if you're watching the instructional videos and you're asked to click on a tool button that you can't see, it's probably because you have not selected the right tab, and if you just look for the correct tab, you should be able to follow along from there. Let me go back to my standard view. This concludes our introduction to the basic features of the targeting cone. In the next video, we're going to see how to start using this targeting cone template file to plan probe trajectories and design a specific version of the targeting cone that will meet the needs of whatever experiment you hope to conduct. So for that, you should go to the next video.